We are going to do exercise number 5 of the problem handout number 2 related with the DTFS, Discrete Time Fourier Series. In this problem, they give to us this signal. It's a periodical signal xn hat, and they ask that we use the properties of the Fourier series. And without explicitly evaluating the Fourier series coefficients, we have to determine whether the following are true for the Fourier series coefficient of this signal a sub k. Okay, so first of all, we see that this is a periodical signal because starting from here and all the way up to here, we can see a period. We see that the left-hand side is a positive 1, train of deltas between -5 and 1. Then starting in 0, the train of deltas goes to -1 and goes all the way up to 5. Okay, so just taking a look at this, we can see that the period of this signal is a period of 10. So n equals to 10. Sorry, here it's going slower. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So every 10 samples we have the same signal to the left, to the right, and also to the left. Okay. So in number 8, they say they ask us the following. They say a sub k. We have to say if it is true or false that a sub k equals to a sub k plus 10 for all k. That's number 8. So that's the answer is true, because we know the property that the a sub k coefficients are periodic, and the period is exactly the same period as the original signal that we take the Fourier transform. Here the Fourier transform, the original signal has period 10. So in general, we can say that for any k, a sub k equals to a sub k plus 10. Okay, here you can see that you cannot see that this is going to happen, obviously, but you can for sure be sure of that. Okay, so that's number A, very easy. It's direct application of one of the properties that we saw in class. Number B, they say that a sub k equals a sub minus k. They ask if this is true. And the answer is not, is false, because as we saw in theory, what we saw really is that a sub k, there is a relationship with a sub minus k, so with the value of k let's say in the mirror with respect to 0 in the k axis, but it's not this property. Really, the property holds when we take the complex conjugate of a sub k. So it's true that there is a relationship between a sub k and a sub minus k, but the relationship is not equality, but is complex conjugate. But this holds whenever, if you see the theory, whenever the signal, in this case the signal is xn, is real. It's a real signal. Okay, so when the signal is real, which is our case, then this property holds. Okay, so this statement, as said in the handout, is false. So in number C, they ask us the following. They say a sub k times e to j k 2 pi divided by 5 is real for all k. They ask us. Okay, so this looks strange. What we are doing is multiplying, let's say in the frequency, we are multiplying the coefficients a sub k, or the series of the coefficients. We are multiplying that by an exponential. So here this has to ring you a bell, and somehow remember one of the properties that we saw in class, which was the following. If we have a signal xn which has a set of coefficients a sub k, and now we wonder what will happen with the coefficients if we take the signal and we displace it a certain amount of time n0. So the answer was, yeah, you can take the same coefficients, a sub k, but the coefficients, each one will be multiplied by an exponential, which is aja minus jk, 2 pi divided by n, where n obviously is the period of xn, times n0. So this is the time shifting property. The time shifting property says that if you time shift the signal, then the coefficients will not, let's say, frequency shift directly, but each of the coefficients will get multiplied by such an exponential. So if you now take a look to our case, you can see that here, let me change the color just to make it more easily to see. You can see here that we have here an exponential here, and here in the question they also show to us another exponential. And what we have to do is just to try to make these two exponentials the same. So you can say the exponential above, you can write it that way. This is a minus jk, and as we have multiplied by a minus sign, we have to put this, and then we multiply by minus 1. Sorry, minus k, sorry, k here is, let me, okay. So the above signal can be expressed this way. So what does this mean? This means that in this case, and then we can put a positive sign here, sorry, a negative sign. It's morning and I'm a little bit sleepy. Okay, so now we can see these expressions together. And what we can see is that in this case, k, the value k equals to minus 1. Okay, equals, sorry, here, sorry, I am being the stupid, this is k, the value n0 equals to minus 1, okay, as you can see over here. So basically this means that the original signal was x minus n0, which is minus 1. So this is x, sorry, this is n, on n plus 1. So what is the conclusion? The conclusion is that this is the Fourier expansion of the signal x, let's say hat, n plus 1. So if we have x n here, x of n plus 1 will have a set of coefficients that is this thing. So they asked to us, remember the question was that basically this is real, and we can, it's the same as saying the coefficients of this signal are real, the coefficients of that signal are real. So the answer is yes. Why? Because basically x, this signal, if x hat is real, this signal is also real. Okay, so basically if this signal is real, then the coefficients will be also real. A sub k will also be real. So the answer in this case is yes. Okay, sorry for the couple of mistakes that I have made speaking, but I hope that is well understood. Okay, let's go for number D. So in number D, they ask to us if a sub 0 equals to 0. This is very easy because if you remember the signal above, basically we have a set of deltas here below and a set of deltas here above. There were how many? There were 5 on the left and 4 to the right. 0, 0, 1, 2, 3, and 4. 1, 2, 3, 4, and 5. That was the signal, and that was the simple, the single period n. Okay, and they ask us if a sub 0 is 0. If you remember, I told you that a sub 0 is exactly the same as the average value of the signal. Because this is just direct application of the formula. The formula, if you apply the formula of the coefficients a sub k for k equal to 0, basically the result is the average value of k. So what is the average value of a signal like this? So in this case, will be clearly 0. The average value of x of n, the DC component, basically is 0. So if you have here 1, 1, 1, 1, 1 5 times, and you have here minus 1, minus 1, minus 1, and minus 1 5 times, and you add everything together, basically the value is 0. The DC component of the signal is 0. So in this case, the answer is yes. I told you, I explained to you in class that it's very quick to see if a signal has an average value or a DC component or not, just taking a look at A0. Okay, so that's the end of the problem. I hope it was clear to you. It's an important problem just to practice the properties of the discrete time Fourier series, and as you can see, we can get a lot of information just by taking a look at the original signal. Without making the DTFS, we can say a lot of things about the way that this signal will look like in frequency. We can say we can see periodicity of the coefficients in the frequency. We can also see how will the positive and the negative frequencies will behave. We can think on how a time shift will affect the coefficients, and finally we can see just by taking a look at the frequency in time if there will be or not any DC component of the signal. Okay, so thank you very much for your attention, and see you in the next video.